Please do allow me to share with you the truth about the South and the North Pole and the flat and geocentric Earth. It's not completely flat, obviously. There's hills, it's got depth to it. I actually saw it in a near-death experience. It's like an upside-down Christmas tree. I couldn't see the stars or anything. It's really, really deep, like a Christmas tree. Just imagine how much space we have on the bottom part of it. But then look how deep it is. I'm about to show you undeniable proof that we live in like a matrix. It's psychological, it's binary, it's got a north and a south pole, it's got an on and an off, it's got a dielectric field, aka the off, the resting, and then it's got an on, electronic, or electric, or energy, or active, like the matrix. The spaceless timelessness, the off, then the space-time, the on. We live in space-time when we're awake. That's why God says when you rest, you're saved. You're saved into that error correcting, self-correcting source code that everything comes from. Well, there's a lot more I could say about that. I've already explained all that in the past in my Matrix video. Like, there's actually about 3 of them that I made. And it's actually all psychological. It's all binary. The physicists found out that the whole world is binary, and it's like got computer code literally written into it. And it's actually totally psychological. And it's holographic at the same time. So one part kind of shows the whole thing. And that's what you got going on with the firmament. It's basically that's how the 24-hour sun at the South Pole happens. It's got to do with Enoch. It's got to do with portals and the heavens and how it all began. Well, you're gonna see. Let me get to the point. I don't want to talk too metaphysically, too deep, and all that, but I want you to understand why what you're about to see happens. Because it shouldn't happen on what most people would consider a flat Earth or a ball Earth. Only way this would happen is on a electromagnetic matrix that is projected from a dielectric disk of some sort called Earth. And it's like a holographic projection that is literally like the firmament itself is the ends of this projection. And for all we know, the heavens are something completely different as far as the firmament and all that. And then the sun and the moon and the stars and the wandering planets, as they call, or wandering stars, they all have their own entirely different orbit. Like, they go from the north to the south. The sun especially does this. This is why the sun marks out a year, is because how it goes north to south. None of the other stars do this. That's because we're on a flat geocentric Earth, and the stars are moving around in the northern pole and the southern pole, that just like in a magnet and just like an electromagnetic field, they spin clockwise and counterclockwise, opposites of each other, and they actually pull on each other and interact with each other. And at the equator, a 24-hour sun is literally impossible, because if you were not to know that there's this visual illusion going on, because at the equator the sun doesn't move more than a few degrees. It maybe moves I don't know, maybe 20 degrees at best. It doesn't move like 180 degrees, like from the north to the south. On the equator, for example, from north to south, it only moves maybe 40 degrees. It doesn't go off like at the equator, it constantly sees the sun, and it hardly even moves because the changes are so minute at the equator, because it's not biased towards the north or the south. But the difference is, at the north and the south are so drastic. You can literally look at this. This shouldn't be possible. This is 180 degrees difference. You see what's over there? The moon. You see this on the top right corner? That's the moon. Now watch this and get mind blown. Do you see what's happening here? What is that in the top left corner? The moon. It's polar opposite. See? It's on the right here, perfectly aligned up. And then on here, it's on the left, perfectly aligned up. And then you see Mars, Saturn, the sun, and the moon. You see how they have their own orbit? Totally different from the stars. You're going to see in a second. I'm going to show you how the stars work. And then Jupiter's following the moon. They all those have their own kind of orbit. And the sun does it north to south in 1 year. These other ones, they're different. I haven't figured them all out. I'm just trying to get you the overall general idea because it's extremely deep. And, I work on the other planets, but the moon and the sun are the main timepieces. But I'm sure the other planets are meant to keep time as well in a completely different way from the stars of heaven, the firmament, because you see they're inside of the firmament, so they're not being orbited in a predictable way every single day by the ether. The day is actually measured out by the ether itself, not the sun. The sun marks out a year, and the moon has a monthly effect, but the constellations do as well. We go through another zodiac every month. We go through another constellation every month. So I think they're more accurate in describing a month than even the moon. But the moon does also do that because it's an important timepiece. The planets, like I said, I haven't figured them out perfectly. And it seems like the moon has either a 1 year or a half-year orbit. Like, I'm not exactly sure yet, but that's quite interesting. And I'm about to show you how these things orbit. And watch how far I am up in the north. Like, I had to literally manually type in this latitude because I wouldn't have been able to press on it on the map. That's how far to the north and the south I'll be going. Just to show you what the south looks like. How far deep I'm going in there. Well, about as far as it goes. Just to show you, I'm going to press up on this and see it doesn't go any further. Now I'm going to show you what it looks like when it's actually in motion, you see. And I'm going to show you they're not, it's not like they said, it's not 6 months of daylight and 6 months of night. It's actually usually like 7 to 8 months of light. And for if you go a little bit, it's actually, you get longer days, I think, if you get a little bit away from the pure poles. Because I was seeing like 8 months at some of the other latitudes, but I'm trying to keep this simple. But basically, you're gonna see. Like, how should I go about this? I'm just gonna play it. You see? Oh, they changed it. Okay. I didn't mean to do that. I didn't know what that meant. I thought that meant play. Set time to now. Oh, I see. That's why I fucked up. I apologize. I'm not exactly a pro at this. Let me go back several years though. Just, you see how the planets are the only thing moving? You see it? That's proof right there. I don't even gotta do nothing else. Let me show you how the moon works too while I'm at it. Is that mother? The moon actually goes back in time too. Like, I'm happy that I got a chance to show you this. Watch the moon. Like, it's going right. Watch how it goes up and down. It does it way faster than the It's no, it's actually going right to left. Yeah, I'm gonna follow it right to left. Because I'm going back in time right now. You know, just getting a pattern. And you're gonna see how it changes its pattern eventually. Now it's all the way over there, you see? I'm thinking it's doing it like twice a year. Is it gonna reverse there? Nope. Nah, you see how it just totally changed its trajectory? See how it was going off there, and then it feels like a spacecraft, dude. Like, it's weird as fuck. But the moon is the most weirdest one of them all, bro. Like, watch this. It's about to go back. Boom. You see that? Oh, I see. That's because it was going back down. Remember, its orbit is way faster than the sun's. Like, you see how the sun's still up there? Watch how long the sun is compared to the moon. Moon's basically what? Like, wondering if it's a year now. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Nah, they're probably both a year. Look at the moon, it's already back though. What the fuck? It's already back. This thing is so fucking trippy, dude. Like, sometimes it comes back real fast. Like, it just depends on the angle. And then sometimes it's only up there for like 4 months. So I think it's like representative of both a season, depending on the angle, and also a whole entire year. That is so fucking deep. And then a month too. And then I guess it has a day as well, because it goes across the sky every day. So the moon is really the absolute timekeeper. I knew these two had to do with Earth and time and everything, because they're echoes of Earth. When I showed you the beginning of time, they were both there. And then these specific planets that were pulled out of the Milky Way that you see here at the south very clearly, which is what I'm pretty sure is representative of this absolutely amazing effect that we get at the South Pole, where we could possibly be actually seeing, you know, a lot of light and all that, but we could also not be seeing a 24-hour. We don't know. That's the problem with not being able to go down there. But either way, it works. If it actually occurs, I have explanation there. You'll see. Like, you haven't even seen nothing yet. About to show you how. I already showed you basically how, you know, they orbit totally different. You know, I don't know why I'm doing that. I need to actually just let it play anyway. So let's go to this winter solstice. Oh, it just did me dirty. Let me get back to location. So, and now let's get back to winter solstice, right? This is the middle of the night, by the way, I'm aiming for. Like, this is what I usually aim for, but for this one, damn, it doesn't ever get there. That's a very interesting effect. How it never actually goes to the middle. I think that's because of the other pole that's making this happen. Because that's how it works, like, you'll see. How do I go about this? Should I do the monthly thing? Just play it. I'm just gonna play it for you. I gotta get it at nighttime though, so you can see what I'm talking about. Maybe I should just go to the equator now and show you how retarded this is. Alright, so let me just go to the equator real quick. I'm gonna show you how this is impossible. I'm gonna show you what 90 degrees looks like. That's what this is. This is 90 degrees I'm changing it. It should be over top. But because it's an electromagnetic field, it has this odd effect. So here, you can't see the sun because it's all the way down there at the South Pole, whatever, right? Doesn't matter if it's zero that or that, but see how many degrees you gotta get it to just to see it again. from the equator. To see it again, you gotta do like 60 degrees. You gotta get pretty close to it. Now I'm gonna show you. Let me go to the. Let me do the north just to make sure everything's the same, because maybe it's not. You never know. Let me get this to the 21st too. I kind of might have to do the other one because of that. Same thing, 60 degrees works for that one as well. So let's try the south again just to make sure, you know. Let me show you, this is like, so it basically needs to be within 30 degrees of the sun to be able to see it. And that's with a sun that's not even going all the way to 90 degrees. See what I'm saying? Like, it's not going all the way to 90 degrees, you see? It just goes along the edge. You can see it. You can see it pretty clearly right here. 80, 70. And that's in midnight, you know, like that's the middle of the night. So let's go to the day. Let's go. See what would be the. Let's see what time would be the best time to see it. I'm showing you all the cool parts. I mean, there's like a lot of cool parts. Let's get this to the right month too. This one's on the 3rd. It's in between the two. It's the equator, so it's in between the two. So let's get this around noon. Yeah, that should work good. Let's pause it. Looks like it needs to be a little before noon, not a little after. Be pretty good lined up. Alright, now let's see how many degrees we have to go. Let's see what 90 degrees looks like. Hold on. Oh, I see. It's going to the north because it's stationed over to the north. So used to doing this the other way around. So if you're over here, you can see it pretty much all the way out to 90 degrees like this. You see? 90 degrees, bro. Now watch when I change the time. You see, this is perfectly aligned over there. Even at the 90 degree axis, you can see this up. When before you couldn't even see it at 30 because of the difference of time. Let me see if it's a nighttime thing. Nope. You can still see it at nighttime. You kidding me? Wow. And it's just doing its usual orbit. This is damn. I told you there's no nighttime in a lot more months than they think, you know, at these poles. Let's see the north. Yeah, pretty much the same thing. Just orbiting the opposite way. You see what's going on here though? It's just the poles. Like, you see how all the stars are orbiting like that? But they don't change at all year, those stars. Like, I'm gonna show you. Let's see, how should I go about it? Should I just go in the middle of the night and then change it by month? You'll see they don't move. But actually I should play it so you can see. Watch this shit. It's already playing. So speed it up. You see? It's all just moving that way because of the magnetic field. But watch me show you how it changes as the months go on. I think actually I'd be better off at the 45 degrees showing this, but let's see. See, now the sun is way closer, but they're still in the same position. And then, you know, 1 month later, it's that much closer. 7. You see how many months of daylight this thing has? Let's count it. Let's count it. Let's go back. That's a lot of fucking months, bro. So we got a little bit of dusk, 24 hours a day, mind you, all day at the north, starting on the fucking second month. So that's 1 month, 2 months, 3 months, 4 months. I feel like I fucked up. 1 month, 2 months, 3 months, 4 months, 5 months, 6 months, 7 months, 8 months. What about 9? Can we get 9? We got 9 fucking months, bro. 9 damn months. They all seem similar in their movement. This is the only place you'll get the planets to orbit in a similar fashion to the to the stars. That's the only way you're gonna ever get it, is when you get it at this kind of angle. What about the south? Let's see. You'll see when I go to the 45th angle. So, well, oh, okay. I want to wait till it's at its dusk though. So there's no way in hell there's 6 months of darkness. You see what I'm saying? There's literally no way in hell. All right, so we got light again. That looked like about 4 months of darkness, maybe 5. So we got light all day. We got a dusk all day. For how many? That's 1, 2, 3, 4, 5, 6, 7, 8. It's just like the North Pole. You see? And the reason it can happen at the South Pole is because there's an electromagnetic effect. Don't you understand? Like, look, you see how the sun is not in the ether? Remember, this is proof of the ether, the firmament. Let me go one more so you can see. See? Constellations up there? The map's not showing the constellations properly. It's supposed to show the damn constellation, like they're doing right here. I guess I have to use this example. I guess they're trying to hide something. Show the constellations. What the heck? But anyways, they're going in a circle right here. That's just so strange they're not showing the constellation. See, none of them move, and this is looking at the Milky Way constantly. But the sun and the planets, you see how they orbit together? Look at that. You see how they orbit together? Totally different. And it seems like, you know, they work in a pack. It's either they usually like in tandem with the moon, I noticed, or the sun. Not exactly sure which ones are focused on what, but it's very complex. And watching, you see how they go back down together? Jupiter's the only one left. And then there's some stars up there showing. You see how the stars like just there all the time? Those are there all the time. They don't change. If this perspective change of the planets and the sun was due to the tilting of the Earth and the spinning of that ball Earth and all that kind of perspective stuff, a lot of this stuff would not be happening. Like a lot of this stuff, like the sun and all the planets would move very similar to the background stars, especially the sun, because it doesn't really change in our perspective on their model. But they all move together just like the Bible said they would. The outer planets move kind of together, and then the inner planets move very close to the sun usually. You know, using globe-trotting language, you know, inner and outer planets. But there's a lot more days of light than they're letting us know. A lot more. Now I'm going to get to these other angles so y'all can see what I'm talking about. The south is the most interesting one. I swear it's always got like the most planets in it. Almost looks like it doesn't even change perspective at all. I think it's just because I'm seeing those planets, those stars back there, but I don't know, the South Pole just seems different to me. I've observed quite a few things about it, like how the planets stick around there longer, I think. It seems like they leave the north much quicker, you see? Could be my imagination though. Like we're at the north right here. You see how the constellation never changes? It's not just at the North Pole, it's at the South Pole, but the perspective looks different. It looks different to the south. I'll show you, because it's not just at 90. It's not just at 90. I'm gonna show you at 45. You go right in the middle.